All right, good morning. We are rolling. How you doing? How's everyone doing?
Great. Yeah.
Yeah. You ready to do some yay math?
Yeah.
Wow. Ooh, panache at the end. I love that word. And it ends with an E. It's awesome. Now we can close the door.
Yeah.
So let's close the door. We're going to do binomial distributions today for statistics. It's pretty interesting, pretty challenging, but I think you can get it. Let's first have a discussion. Start with a real world problem. Suppose, according to Retail Market Group, this is actually true information. Retail Market Group says that the probability of anyone recognizing the brand McDonald's is 95%. So does that make sense?
Yeah.
Yeah, probability that anyone will recognize McDonald's is 95%. That's 19 out of 20 people. That one person, is like, whatever. I don't care. Yeah. Suppose we select 5 people randomly. What's the probability that all 5 will recognize McDonald's? So we're going to answer that question after today. What's the probability that only 4 will recognize McDonald's, given that each person's probability is 95%? And what's the probability of 3 people, or 2, or 1, or 0? We can do all that stuff after today. Okay? And that's what this field helps us discover. So let's first understand what this scenario means. This scenario is called a binomial distribution, and it has 4 characteristics. Let's talk about it. In a binomial distribution, first of all, what is bi prefix for? 2, right? So it's 2. It's basically comparing between yes or no. Okay? And it has, that's the fixed number independent. That's the last one here. Success or failure. Here we go. Let's start with this. So I go up one more, so we go in order. Fixed number of trials. So in this case, 5 people. 5 people are being selected. Person 1, person 2, person 3, person 4. That's important of a binomial. Next is independent. Is it true, like if I surveyed you and find out whether you know McDonald's, that wouldn't affect whether you know McDonald's? Is that true? You know it or you don't. So each trial is independent from each other. Does that make sense? Mm-hmm. Okay. And then the third is that it's success or failure. That's the bi part. Either success or failure, 2 categories. There's no overlapping categories. So we either recognize McDonald's or you don't. And finally, the probability of success remains the same in all cases. Okay, so it's always 95% per person. Now let's see if we can answer the question. What is the probability that all 5 recognize McDonald's? So we've done this. It's a probability involving or and. Which one? And it is. Is it safe to say that the probability of the first person recognizing McDonald's and this person, and this person, and would be all 5? That'd be all 5. Okay? So what's the probability of the first person recognizing the brand? Okay, I'll write that as a decimal. 0.95 for this person. What's the probability of the second person? 0.95. And third. And fourth.
495.
And fifth. There you go.
495.
Actually, we're not the kids. Thank you for that. By the way, I am Pete today.
Yeah, what is that?
I bought this from a second-hand store. This is Pete. Yeah, it is a bowling shirt, actually, for the fire department.
Mathematics.
Yeah.
Statistics.
Probability Pete.
Probability Pete.
That's a good one.
That's my name, and I bowl too. What are the chances?
Yeah.
What are the chances of you getting a strike 3 times in a row?
Depends on how good you are.
Depends on how good you are. Let's do a case study. So is it safe to say that we want probability of person 1 and 2 and 3 and 4 and 5? So what do you do with probabilities when you're anding them? Multiply. Bless your soul. Forever. And what is this number? Can someone tell us?
0.77.
Yeah.
Point
773.
773, which is what percent? 77.3%. Let's own it for a second. Does that make sense? Is that realistic?
774.
0.774? Okay. Yeah, because you round this.
Yeah.
All right, let's do that. And it sort of makes sense. Hopefully it makes sense. And the idea is that Yeah, if there's a 95% chance of each person, then wouldn't it make sense that as you get more and more people, the probability of all of them is going to decrease slightly? Yeah. Questions about that?
Who doesn't recognize McDonald's?
People that are in villages or people that are
Wait, is this everywhere
Yeah,
around
the
the world?
world.
worldwide.
Oh, okay.
Worldwide.
Have you seen Breaking Almonds?
Yeah. Doing our project.
Now let's try probability of 4 recognizing McDonald's. Okay? So there's 5 lines here. So what's the probability of the first person?
0.95.
Let's do 0.95. Next.
0.95.
Next.
0.95.
0.94.
Next. And the last person,
0.05.
0.05.
Why?
This is
The
the
other.
person, thank you for asking. This is the person who does not recognize McDonald's. Would it make sense that if there's a 95% chance of recognizing, there's a 5% chance of not? Is that what you're going to ask? Yeah, that's right. I saw one of these. Yes? Sure, totally. What's the probability of recognizing McDonald's? 95%? What's the probability of then not recognizing it? 5%. And this is 4 out of 5 recognizing.
Okay.
All right? So we would do this, except there's a problem. There's a problem here. Because this is only one scenario. This is the scenario of recognize, 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 not.
Why
But it can be like,
Because this is the probability that the 5th person,
crap.
But the number wouldn't be any different if the 0.05 was first.
it would. It's another way you can arrange 5 people to recognize or not.
Isn't that the associative property, or one of those properties that multiplication doesn't matter at
Oh,
all?
correct. Multiplicatively, whoa, that was a cool word.
Yeah.
With regards to multiplication, the math is the same, correct. You're saying that if 4.5 is over here, the number will be the same if you multiply. However, the situation is different. The situation is, this is only acknowledging the 5th person, not recognizing the brand, McDonald's. What about the 4th person, or the 3rd, or the 2nd, or the 1st? That could also happen. So this problem becomes now complicated.
But it would be the same. It would be the
It
same.
would be the same for each.
Yeah.
Yeah. So do you agree that this is one way it could happen, that 4 out of 5 recognize McDonald's? Another way would be if 0.05 was here, it would be the same number, the same probability. Another way if 0.05 was here, or
So order
here,
matters?
or here. The order matters in terms of which person recognizes it.
But it doesn't matter, like,
Number.
it doesn't have to be like the first person recognized. It doesn't, like, there's no like specific.
No, it doesn't have to.
It just, we have to acknowledge that everybody has the opportunity to not recognize it.
Well said. Everyone has the opportunity to be the person who does not recognize it. You're such an equal opportunity McDonald's recognizer. Yeah, so if you look closely, this is one scenario, and there are 5 of them. So this becomes a challenging problem. Let's actually flip the page. Go here, because I don't want you to do that every time. Let's read this. To realize the number of arrangements to have 4 successes and 1 failure is 5C4. There are. Let's redefine what this means. The number of ways to arrange. Yeah, it's a combination. Number of ways to arrange what?
Anything that matters. The order matters.
Everything.
Order doesn't necessarily matter here. It's just a different group. 4 things out of how many?
5.
5. So this is the number of arrangements of 4 out of 5 to choose from. Can we get this number, please? It is 5. In other words, if you have 5 people,
5.
the number of groups of 4 existing inside would be 5. Think about that for a second. Is that okay?
Yeah.
Is that okay? Yeah?
Can you repeat that?
Yes. If you have 5 people, the number of different groups of 4 is 5.
Okay.
Person 1, 2, 3, 4, that's one group. 1, 2, 3, 5, that's another group. 1, 2, 4, 5, that's another group. And 2, 3, 4, 5. Did I get them all?
1, 3, 4.
1, 3, 4, 5, I missed that one. Basically moving this one over. This is one group, 1, 2, 3, 4, and move this one over. 1, 2, 3, 5. You move this one over. 1, 2, 4, 5. 1, 3, 4, 5. So there's your 5 groups of 4. I feel like this is that crucial moment where either I'm going to make or break the lesson. This is it. This is the moment. Either we're going to get it or we're not. So, this is the math behind it. There are, let's put it up here. I typed these notes myself. I'm very proud.
They're fancy.
This is 5 ways to arrange a group of 4. These are the 4 successes, and this is the 1 failure. So this results in 0.2036, 20% or so. Okay? In other words, remember this math was from above here. This is 4 successes, 1 failure. We do that. This is 0.95 to the 4, and this is 0.05 to the 1. But how many of these scenarios exist?
5.
5. I can't describe how relieved I am that you said that. This is one scenario, right? Let me ask you this, Cornelius. 0.05 can be here, right?
Right.
And that's this scenario. 95, 95, 95, 95, 05. But 0.05 could also be here, right? That's another scenario. Wouldn't it still be 4 95s and an 05? Or 4 95s and an 05 under the hand? That's another one of these. So there's 5 of these. There's 5 ways we can do this. Is that okay? You're sure? There's 5 ways we can do this.
But they're all the same.
But they're all the same, mathematically speaking, by the commutative property as I demonstrated up here. Yes, please.
That makes sense, but why would we have to include the 5C4 if it doesn't change? The fact that it's in different locations doesn't change the probability.
Right, it doesn't change the math. We're always doing 4 successes and 1 failure, but this is the number of groups of that. The number of times that's possible. As we said here with Ecclesiastes, he said the number of ways to give an opportunity for the person who does not know. Now, I'm going to give you some really good news. I'm going to give you some really, really good news. You can do all this on the calculator.
Yeah.
All of this on the calculator. And that's where we break off from the traditional statistics model. We're going to give you one more example numerically. This is the probability that 3 out of 5 recognize the brand. So, how many groups of 3 exist out of 5? Can you tell me? How many groups of 3 exist out of 5? Let's put it up. 5.
10.
It's 10, huh?
How would you do that fast?
They just do it on the calculator.
Oh.
Yeah, so there's 10. So who said, did you say 10? Could you explain what 10 means? I'll start you off. There are.
So in 3 successes out of 5,
Right?
there's 10 like possible combinations.
There's 10 possible ways to have 3 successes out of 5. That's right. There's 10 ways to have 3 out of 5. So in other words, back up to this scenario. I always like this, it helps me. There's 10 ways to have 3 95s and 2 05s. There's 10 ways to do that. But the math is always the same. The math is always the same. There's 10 ways. But you're still going to have 3 of these and 2 of these. And that will result in 21%. Yes?
So that's your probability
This is the probability, yes.
of
2%.
only
2%.
2%, thanks.
that's your probability
Yeah.
of
Of
only 3 people recognizing McDonald's.
out of 5. Does that make sense? Does that like fit?
It does.
95% of people recognize McDonald's, so 3 out of 5 of them? Maybe.
I feel like it's really low.
It's pretty low
Like, I don't know how it went down that much.
because 95 is very high. So the probability of 2 recognizing, or excuse me, the probability of 2, where'd it go? Not recognizing this thing, the 2
Yeah.
not recognizing, makes the fraction very small. 0.05 squared is 0.05. .0025. See how this makes the result very small?
But it shows you that with companies
Yeah.
like McDonald's, it's really important to get the most number of people to see your product.
This is what we're getting
Because
at. Yeah.
a number, like out of 5 people, losing 1 person really drops down your
Really drops.
chances
But
of getting them to come to your.
You're in the right path now. The idea is that the reason this is so low, the reason it's 2% is so low, 3 out of 5 recognizing, is actually good for McDonald's. Because they're acknowledging that the chances that 2 people do not recognize brings the probability very low. It's 0.05 times 0.05. And that makes this, ultimately, weighs down the percentile, or the percent. It brings it really low. So that's actually good for them. Yes?
Where did you get .0025?
That's 0.05 times 0.05. That's the square. And then you can do 0.95 3 times. Can someone give me this number?
0.857.
0.857. So if you multiply these 3, you'll get 0.0214. Okay? Now the good news. Let's go into the calculator. It's fascinating that it actually exists there. So here it is. The calculation is binom PDF, binomial distribution. Okay? It works as follows with NPR, no pun intended. Yeah.
National Public Radio.
That is the pun, but I don't intend it to be that. Okay, let's actually explore. So why don't you get here and I'll catch up to you. Hit second vers. So clear this. Second. Where'd it go? Vers.
And the shortcut is alpha A.
Oh, it's down there? Binom PDF. So I'll scroll to alpha A, huh?
Where is?
Want me to do it again?
Yeah.
Sure. There it is. Getting out. Getting out. There you go. So hit second and then the vers key.
Oh, okay.
And now scrolling down. Scrolling down. And we said in the front here is alpha A. Stop. Okay. Go. Boom. You actually have it here. Many of you don't have it this way. You just have it like sort of parentheses
it.
method.
Yeah, just
You have parentheses method?
Yes, right now.
Okay. Parentheses method is no different. I'll just give it to you. It'll be like binom PDF. And it goes like that. Okay? First step.
Sorry.
Whoa! Vandalism! Tag my wall. Tag it. Let's go up. Let's get out of here. Get out of here. There you go. Okay. N is the first one. Number of trials. In this case, the number of trials is 5. So we put 5 in for our number of trials. 5. Now I'm going to take the vandalism off, okay? Bye, vandalism. Do it. All right. Back. 5. P is the probability of success. What is the probability of success?
3.
The probability of success? 0.95. You're getting, we'll do 3 next.
So if you don't have that, you just multiply it by 0.25.
Don't have what?
The drop down, you just have.
Oh, you put comma. Like this.
Eureka!
It's comma.
I found it.
You found it, great.
What is the trials mean?
Wow.
Trials is the number of people you're taking to recognize the brand. In this case, it's 5.
Value.
Okay?
It's horrible. I didn't start
So
yesterday.
probability of success for each person is 0.95. Again, this is fixed. This does not change. That's part of the characteristics of a binomial. And the x value is the number of successes. How many successes do we want in this particular case? The most recent one?
3.
3. Let's put 3 in. Enter. And paste. And in fact, it gives it to us the same way you have it in your calculator. And we hit enter.
Whoa.
Yeah.
Very cool.
That's so exciting.
It's very exciting. It's very exciting because you don't have to deal with the whole lengthy formula. Let's verify that we get the same thing for 5 successes, the problem we did at the beginning. So the way to recall this, by the way, if you don't know, is second enter. If you hit second enter, it brings it right back up, the last thing that you just did. And now, so let's do it. Number of trials, 5. Chance for success, 0.95. Number of successes, what do we want to do now? The first problem we did. First one before that.
Oh, 5.
5. Let's do 5. What do we expect to see before we hit enter?
0.773.
0.773.
Yeah.
Yeah.
Let's do 4.
Oh,
That's so
Nice.
cool.
It's very good. It's like it's such a relief. Honestly, because why deal with all the formula crunching? It gets away from the point. I'd rather discuss the problem contextually with you, and then just let you calculate it like a normal person.
How do you what's the undo button?
Undo?
Yeah.
There is no undo.
I thought you said there's something.
Yeah, there is.
Undo? Well, it's not undo previous.
Yeah.
There's a second insert. You can insert stuff by hitting second delete. Okay. Ready for the advanced calculator one?
Yeah.
Yeah, you are.
Woo! Hey, man.
Well, you know, it's just as cool. It's just as cool as this, except it gives you more functionality. If you think this is cool, then you'll like the following. Okay. The next one is actually using the table. You could actually say, I don't want it for a set number of childs. Watch. Let's go back here. If I go second enter, let's bring it back. Let's clear this. Clear, enter. And then close. Okay, look closely. This is the number of trials. This is the success per trial. Have I discussed how many successes I want yet?
No.
No, I haven't discussed. So this will do it for every single situation.
That's so cool.
This will do it for every single. So I hit enter. Is there any questions about that? I haven't discussed successes here.
so what do you put in when you get to the trial, to the page where it says trial X? I mean trial P X.
P would be 0.95. X you leave blank.
Oh, you just leave it.
Leave blank, and you get this. Now this is the list. This is the list of answers. This is the list of answers. So now what we're going to do is we're going to store this. Hit store, and store my answer. My answer is a list of numbers, and we're going to store it into the column L2. Second 2 would give you L2. So store it into L2. And now let's look at the table by
Wait,
hitting
how do you get the arrow?
stores right here.
Okay.
Stat edit. Oh, I wanted to clear this out. I want to clear this out. So
It's there.
yeah, it's there. It's there. I want to clear my tables. So I'm going to clear my tables. That's second memory. 4. Clear all this. Clear all this. There we go. I'm going to do it again. Shall we do it again?
Yeah.
Let's do it again.
Sweet.
So second enter. Second enter. Second enter. Great. Do we have this? We hit enter. The answer is, this is the list of numbers for all successes. All successes are here as a list. I want to take my answers and store them, store my answer list into the column L2. L2 is accessible by the button second 2, right here, second 2. And you notice we see store into L2. Hit enter. Now I've stored my list into L2. I go to stat and edit, and there they are. These are the answers for each number of successes. 0 successes, 1 success, 2 successes, 3, 4, and 5. Do these numbers look familiar based on what we've been calculating?
Not the first 2.
Because we haven't done it. So the chance of no one recognizing McDonald's out of 5 people is exceedingly what? Small. The chance of 1 person out of 5 recognizing McDonald's is also very small.
Oh, that means the scientific.
Scientific notation, 3 times 10
It's a
to the negative 5, right? So it's basically 4 zeros and 3. Exceedingly small. And would that make sense? Would it make sense? 0.000003.
I literally have no idea. Sorry.
That if there's a 95% chance of recognizing McDonald's for each person, that if 1 out of 5 recognize it, chances are pretty low. That you get like probably more than 1 person. And then this is the chance of 2 people, 3 people out of 5, 4 people out of 5, 5 people out of 5. All right? And what do you think all these numbers add up to?
100?
100%. Good job. Numerically, which is?
One.
1. Very good.
Wait, how do you get to the actual table?
Table, stack. You guys, you did really well. Good job. Thank you, everyone. Say goodbye. Bye.